Hello friends, welcome back. In the last session we have stopped in solving this particular problem due to some unforeseen issues. I am just completing that particular problem. We'll finish it in couple of minutes. So where we stopped is we started with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, which is a second degree non-homogeneous equation which represents a pair of straight lines. So we found out what is the relation between L's and M's and with respect to A, B, C. So we have L1, L2 equal to A, M1, M2 equal to B, N1, N2 equal to C, and respectively remaining all. So we solved for a pair of linear equation in two variables. We found out x equal to m2 n1 minus m1 m2 m1 n2 divided by l1 m2 minus l2 m1. Now we have whatever the conditions we have it on the left hand side. Now we have to convert these negatives into positives so that we can substitute L's, M's and N's in terms of A, B, C and F, G, H. So let's go ahead and do that. The next step will be, I'll try to write them as positives. So for that what I will do, I'll write it as minus of, I will say x equal to minus of, can I say m1 n2 m1 n2 minus m2 n1 multiply with L1 m2 minus L2 m1 divided by whatever we have, that is L1 m2 minus L2 m1 whole square. Now this is nothing but equal to, now I will write it as, I will take that negative 2 down, will write it as minus of L1 m2 minus L2 m1 whole square, and here I will have now m1 m2, I will have m1 n2 minus m2 m1 into this. I will write them as plus now first. Let us see what I can do with that. So I will write them as plus now. I will write it as m1 into n2 plus m2 into n1, multiply that with L1 into m2 plus L2 into m1 minus of. Now let's compare this. I have where negative terms m1 n2 into L2 m1, that should be negative, but now I am taking it as positive. So what I have to do, if it is minus x, I have to write it as x minus 2x. So my next step will be, I will write it as minus of 2, where I will have the negative term, that is nothing but minus 2 L2 m1 m2 L2 m1 m2 n1, another one will be minus 2 L1 m1 m2 n2. So if you take m1 m2 common, you will have directly minus 2 m1 m2 into L1 n2 plus L2 n1, which is pretty straightforward, so we can solve it easily now. Next step will be, so let's write down the next step. The next step will be x equal to, we'll write down here, x equal to m1 n2 m1 n2 plus m2 n1, multiply that with L1 m2 plus L2 m1, subtract. I said we can take 2 m1 m2 common, so it will become minus 2 m1 m2 into L1 n2 plus L2 n1, and in the denominator we will have minus of, can I write it as L1 m2 plus L2 m1 whole square. What are we doing is a minus b whole square equal to a plus b whole square minus 4ab, that is 4 L1 L2 m1 m2. Now let's go ahead and substitute the values whatever we have in terms of L and A, in terms of ABC. m1 m2 plus m2 n1 is nothing but equal to 2f, so I can write down 2f into 2h for L1 m2 plus L2 m1, we know that minus of 2 into m1 m2 is b into L1 n2 plus L2 n1 is nothing but equal to 2g divided by minus of L1 m2 plus L2 m1 whole square is 2h whole square, that is 4h square, minus 4 into L1 L2 is A, m1 m2 is B. So the next step will be 4hf minus 4bg divided by 4ab minus 4h square. Can I take 4 common? I will have 4 into hf minus bg divided by 4 into ab minus h square. Now 4 will cancel out. We get our final answer, that is hf minus bg divided by ab minus h square. Now you can try in the similar lines to find out the value of y also. For that, what we will do, we will take again L1x plus m1y plus n1 equal to 0, L2x plus m2y plus n2 equal to 0. This time we eliminate y variable, we eliminate x variable, we will get the value of y in terms of L's and m's and n's. Then again we will leverage whatever the existing conditions whatever we have or the values we have, comparison between L, M, N and A, B, C, F, G, H. We leverage them, we convert them into positives, right, in terms of whatever we know and try to get the value. So that's how we can find out the value of the point coordinates of the point of coordinates of the point, which is point of intersection of pair of straight lines in case of non-homogeneous second degree equation given by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So I thought of sharing this with you, the method which you generally don't see in the textbook. I explored it. I thought maybe I should be able to just present this to you. Okay, so I'll catch you once again with another interesting concept. We are covering pair of straight lines as part of coordinate geometry 11th grade syllabus. So I'll catch you in the next session. Till then, keep smiling and sharing. Thanks for your time and support. Bye for now.